or 5. Hello, my name is Jack Armstrong with Acumen Consulting. I'm a chemical engineer by training and have been in the building materials product space for over 30 years. So I'm delighted today to be presenting to you the Environmental Product Declarations and Graphite Polystyrene Insulated Vinyl Siding Nano course. Today you'll be receiving half credit for this AIA Continuing Education Certified course in Health, Safety, Welfare. Our course description, this is kind of an adjunct, if you will, to the 1-hour course, which is called Not Your Grandmother's Vinyl Siding, the Advantages of Graphite Polystyrene Insulated Vinyl Siding. This course is considered an intermediate level course, and you hopefully will have already seen the previous full course because it sets the context for the material that we're going to be continuing on today. Our learning objectives, short and sweet, 3 of them for our half-hour credit here. First, we'll hit on and describe what an environmental product declaration is, as well as the life cycle analysis, or what's called LCA. Secondarily, we're going to explain why and how EPDs are being used to measure and track carbon in public projects, as well as green building programs, carbon calculators, and various other software programs. And lastly, we will talk about the use of EPDs and some of the environmental benefits of insulated vinyl siding systems. So, learning objective number 1, what are EPDs and how do we use them in sustainable design? So, EPDs, once again, standing for Environmental Product Declaration, is a sustainability decision-making tool. They allow for comparison with products using the same function. They were first created in Sweden a couple of decades ago, towards the end of the 1990s, and it is an abbreviated form of the life cycle analysis, or the LCA. EPDs can be industry-wide EPDs, which means it's an average of a variety of manufacturers in a particular geographical area, or they can be product specific from one specific manufacturer. They can vary in scope according to the various life cycle stages, which we'll get to in a little bit. But in short, an EPD is your friend because it allows you to take a quite complicated life cycle analysis report, which could be hundreds of pages, and it simplifies it down in kind of a Reader's Digest condensed version, Cliff Notes version, to the most important environmental product declaration information that typically is done anywhere from, say, 3 or 4 to, say, 5 to 8 pages. So what does one look like, actually? Well, here we've done 2 clippings from industry-wide and product-specific environmental product declarations, which there are thousands available on the internet. The first one to the right-hand side, you see, is an industry-wide. And this particular one is for the Vinyl Siding Institute industry for insulated vinyl siding. The one to the left in blue is actually a product-specific one. And in this case, it's from the graphite enhanced polystyrene insulation provided by BASF. That typically is the insulation that goes and is adhered on the back of vinyl siding. So, how are EPDs really created? Well, as I mentioned in the previous example, EPDs actually start from a life cycle analysis. So, a life cycle analysis is a large kind of multi-tiered product that maybe takes 3 to 6 months to come up with. It can cost $30,000 to $40,000 to put something together like this. But most importantly, it goes through all stages of the life cycle. From that, extraction of raw materials, shipping those to a manufacturing location, production of a particular product, shipping to the job site, installation in the job site, all that we will call embodied energy, and we get to that in a second. And then the use phase, and then on to final end-of-life stages. The EPD itself extracts the environmental information from the life cycle analysis according to a set of rules, which we call product category rules, or PCRs. And essentially what the PCR allows you to do is take an entire industry, consider it, say, flooring or roofing or wallpaper, or in this case, insulated siding, and use the same set of rules, the same set of measurements as a functional unit. It may be a 1 square foot by 1 square foot installed piece of siding, or it could be a square meter or square yard of flooring. But the whole idea of the product category rules is that everybody in that industry gets together and agrees on what the unit of measure is. So then you can have apples to apples comparisons of the variety of different versions of that particular product from multiple manufacturers. Then you submit that information to a third-party program operator or provider, and you can see a variety of these in the lower right-hand corner here under the red rectangle. So whether it's something like UL Environmental, ASTM International, Carbon Leadership Forum, there are many other versions and competing companies around the world. Could be EPD Hub that actually not only prepare these, but verify them if they have been prepared by an individual manufacturer, or many times they work on behalf of the whole industry to get the industry average. So since we did talk a little bit about life cycle analysis and life cycle assessments, let's see really what that means. So this is a little bit of an eye chart here. So we'll spend a few minutes to kind of step you through so you can feel comfortable with what this really means. So on the very left-hand side there, in the column where you see the circles of black, 1, 2, 3, 4, 5, those are the individual life cycle stages. So parallel horizontally to life cycle stage number 1 is the production of the product. So the production actually means extraction of the raw materials, where you can see actually A1. It can be the transportation of those raw materials to the factory, that'd be A2. And then it can be the manufacturing of that particular item, which would be A3. So for example, if you're making aluminum windows, maybe it actually starts with the extraction of the bauxite, the creation of the aluminum. The aluminum gets transported to a manufacturer that's actually going to be making the windows. In addition, there'd be some glass. So there might be sand that's turned into glass that's then shipped over to manufacturing to actually make the final window product. And that's what we can see over here in the far right-hand side, cradle to gate environmental product declaration. So that's the smallest, the thinnest, the most brief portion of an EPD that can exist. And then let's say you're going to actually send that particular product to a job site, then that's where number 2 starts in the black circle, and that's the construction process. So when we say cradle to gate, it's gate of the manufacturing facility. Then you ship from the manufacturing facility to the job site, which is A4. And this is where you might consider if you're having, say, fancy windows produced in Germany and you're shipping them to Philadelphia, that environmental burden of shipping would happen in A4. And then A5 is what happens actually assembling the windows or vinyl insulated siding product onto the building itself. All that together, this item 1 plus item 2, is what we call embodied energy. Then you hop over to the next phase, which is the use phase of the building. And sometimes an environmental product declaration may or may not include that particular phase. Oftentimes you always get the slice number 1 at the top, the production, which is cradle to gate. But many times nowadays, you actually get the construction process piece where there's an assumption that the building was constructed with this particular item. And so you have full embodied energy. As we transition into the use phase, where item number 3, the black circle, is showing, that's really the use phase of the building once people move into it and it's already constructed. So you have elements B1 through B7. So B1 is the use phase of the building and the products in the building. B2 is any maintenance or repair, B3 and B4. So for example, if we're thinking about carpeting, you'd be using the carpeting in the building, you'd be maintaining the carpeting, you'd be occasionally shampooing it, you might have to change it every so often and replace it, refurbishment. And then B6 is operational energy of paying the light bill, paying the gas bill for heating and cooling the building. And then B7 is operational water that's going on the building. So it's more than just the toilets and washing your hands and the sinks, but it could be things like HVAC, where you're heating and ventilation, cooling towers, and things of that nature. So this use phase can be 30, 50, 80, 100 years. And that's when we say a cradle to grave environmental product declaration. So that's almost everything that you would want to consider. Now, we know at the end of the life cycle stage of a building, vis-a-vis when we're going to tear it down or we're going to be removing products from the building, that's what's considered and contemplated in this circle number 4, end of life stages. So there we have these C categories: deconstruction of the building, transportation of the elements from the building to either some offsite storage facility or some offsite processing facility, where you see here in C3, waste processing. And then it could be disposal as well. So maybe that's directly to a landfill. However, you have the opportunity also with many of these products, much like the insulated vinyl siding product, where you can go to the very last phase here, which is D, for recycling, recovery, and reuse. And that's really the gold standard. That's where we see over here cradle to cradle EPD. Many of you may be familiar with the Bill McDonough book that was written back in the 1990s called Cradle to Cradle. Today, we talk a lot about circular economy, and that's kind of what we mean now when we talk about cradle to cradle. So now that we've given you a little bit of perspective on what is a life cycle analysis, how does it all come together, how we extract pieces of that to have this nice little comparative tool called an product declaration, what do we do with those? And then how can we use them to compare products? So let's move right into that. So now that we have our EPD, certainly they are critical for carbon reporting. And we're going to know things like what kind of energy was used to produce the particular product, what kind of water was used, what kind of, was it renewable energy versus unrenewable energy, as well as any type of emissions, both to water as well as the air that comes from that particular product. As you can see there, EPD has been critical for carbon reporting. Not only is it showing, depending on the life cycle perspective of that EPD, whether it's just embodied energy, these upfront emissions that go into the products when you actually provide a product to the job site, or if it actually has the life cycle stages, which is really the gold standard with which you would want to have. Third rectangle there, you see many of these are now incentivized, because whether it's like a USGBC's LEED rating program, or the UK program BREEAM, or Green Star, Green Globes, the National Green Building Standard, ICC 700, these are all allowing for credits if people have transparency reporting for the raw materials going in. And an EPD is a big part of that. Lastly, more than ever, because many people have geographical carbon goals, whether you're a state, a municipality, somewhere like California or Texas, or maybe cities, the city of Austin, New York City, the city of Portland, are requiring that you have transparency documentation for the products that go into building and construction. So EPDs, the nice thing to consider is that they're standardized, and they have to apply to many of these and adhere to many of these ISO global standards and ASTM national standards here in North America. But they do help satisfy many of the Buy Clean initiatives that you see, where people are saying, gosh, I'm building a school, I'm building a municipal building, I'm building a federal building. I need to meet a certain carbon intensity for this particular building. EPDs are imperative for that, as well as many of the new incentive programs that are out there today, whether it's the Recovery Investment Act or some of the Environmental Protection Agency programs for green economy and sustainability in building. Additionally, there's the Housing Supply Action Plan. This often comes from the Housing and Urban Development and some of the other governmental entities. But the first bullet point there that you see, the Home Investment Partnerships Program, HOME Act as it was called, it's $1.5 billion that goes to over almost 700 participating jurisdictions around the country for affordable housing. Then we have the Community Development Block Grants, those CDBG block grants. And there you can see over $3.3 billion going to over 1,200 states, municipalities, for stronger building of communities, resilient communities, and so forth. And some of these actually, as you can see in the bottom, are also not only for new construction, but the Green and Resilient Retrofit Program, this GRRP, as many people refer to, is specifically looking at repair and maintenance and upgrading of existing facilities. And there's a loan program that's available for everybody there. So now that we have all these EPDs, how are we really using them and comparing and contrasting them? So there's a whole universe, and you might say an organizational network out there with a lot of different programs that exist today, where you have already existing programs like BIMSmith and SpecLink and MasterSpec, and even the new BEAM tool that is for the residential industry. And these programs are accumulating many of the documented specifications as well as pieces for environmental information that come from EPDs. Oftentimes, these are help feeding programs like EC3, which stands for the Embodied Carbon and Construction Calculator tool. That's the 3 C's of the 3. And essentially think of it as a database that brings in all EPDs and allows you to compare and contrast and sort them. There's also a part of the EC3 tool that tries to aggregate multiple EPDs together. They call it the tally tool. And then what you can do is communicate with your BIM systems, like a Revit system or many of the other systems, Bentley and so forth, to try and aggregate each individual piece of the building that's in the design and actually be able to come up with a whole building LCA. So kind of the gold standard of what am I really doing and how can I say the carbon intensity of this building per square foot, for example. So if you were to go into one of these tools, like say the EC3 tool, where this is a screenshot, and we did a search for foam sheathing, you can get a variety of different information from the different companies that provide it, the different locations where the raw materials perhaps are coming from, the various products that are involved there in the center. You can see all the way over to the next to last column where you actually see the global warming potential, the carbon intensity of those particular products. So for example, the top line there for BASF Corporation, type 1 insulation, 0.1607 kilograms of carbon equivalent. So as you go up and down the list, you can see the various flavors of rigid insulation that are used, and you can see the various high and low numbers. So line number 3 here, you see that one is over 7 kilograms, where just above it was 0.1 kilogram. So this provides an example to do some comparisons. And then the tools like the EC3 tool will actually chart this out and graph it. And they'll show you an industry average for what the whole microcosm of this particular product category is on average. And then the individual manufacturers above and below the line will be plotted. So you can decide, well, gosh, based on my goal and intention of which product do I want to use, say in this case, as a foam sheathing product, you can say, I want people that are better than average. So that way you know which to contact. Changing gears here as we start to wind down, let's talk a bit about our last learning objective. So an example of how EPD findings were used for graphite polystyrene insulated vinyl siding. So first, to just talk a little bit about this idea when we speak to operational energy versus embodied energy. So once again, embodied energy is all of that upfront invested energy and material inputs that went into making the product. And if we focus on the right-hand side of the page over here, where we see the 2 little houses, so let's do an example of expandable polystyrene, say traditional white EPS on the bottom, versus an enhanced recipe called graphite enhanced polystyrene or graphite polystyrene. And in both cases, we have a ton of material, 1,000 kilograms of material. So the top is the GPS with the enhanced carbon insulation power, and the lower one is a traditional EPS with a lower R value. So in order to insulate the building at the specific R value of that you're desiring, you'd be able to do the whole building up here with this 450 square meters of rigid board GPS versus the lower R value material, which is the white EPS, wouldn't be able to finish the whole job. So the idea that we're trying to show here is with the same amount of material, oftentimes, if you have a higher R value of 1, then you can actually use less material to do the whole job, which is what you're seeing here. You're able, in the top gray example, to finish insulating the whole wall, whereas you're only getting 2/3 of the way there on the lower example. So kind of what this means, if we come over here to the left-hand side now, less density with more R value means less carbon. So if you can do the same job with less material, then obviously you can have a lower carbon footprint if it indeed has the same R value. So that's kind of the idea. So in the first red rectangle here, we're seeing less embodied energy carbon than any other rigid insulation in North America is the example of the gray graphite enhanced polystyrene foam, which they call here Neopor. In the middle rectangle here, we talk about being able to have 30% less material, less weight, less mass when you compare to, say, extruded polystyrene for the same R value. So that's important. And then lastly, on average, when we look at a gray carbon enhanced EPS versus a traditional white EPS, you're getting about 25% more R value. So when we look at different products in the marketplace, you can see that there's a true advantage if you can have lower weight, lower mass material, but the same R value or a higher R value. So as we start to kind of take that power of what we've learned there and look at one of the recent studies that was done by a group of architects, KPMB architects, they actually said, okay, well, let's think about a variety of foam sheathing opportunities and products that are out there. And let's graph the carbon intensity here in the vertical axis, going up and down on the y-axis, based on R value. So let's say, for example, we want to have an R value on the horizontal x-axis here of R value of 30 in imperial units here, not metric units. So how much carbon would it take in the various forms of rigid board stock insulation to do R30? So the lowest numbers here, they're all so close to one another. They're kind of run together, and you can see the exploded view here between cellulose and fiberglass and Neopor graphite polystyrene insulation. They're almost all kind of together in the same little band down there. But the standout ones are extruded polystyrene. So XPS, regardless of which flavor and which company, companies have been reformulating them. But you can see if you're going to say have an R value of 30, the yellow lines and the orangish lines here are about 30 kilograms of carbon for that one embodied energy footprint that's installed in the building, versus up here in the blue category, you're well over 500. So you can start to see the power of an EPD illustrating to you your ability to understand how much carbon it takes as embodied energy to do the same job. So now that we know, gosh, if I have a R30 input and there's a variety of different carbons intensities, what does that really mean? So the major takeaway here is sometimes in the red boxes that you see over here, extruded polystyrene has 15 to 20 times more global warming potential than many of the comparative products, whether it's, say, blown-in cellulose, which happens to be the lowest, and which makes sense because blown-in cellulose is typically made from recycled newspaper, which is cellulose. It comes from renewable sources like trees and things. And then right along in there with the pack, so to speak, is the graphite polystyrene insulation with a low embodied energy value as well. So as we go to say, well, why does that really matter, Jack? If we ran a life cycle analysis, and here you can see carbon payback analysis of heating a building with natural gas from 0 years to 16 years. And so the idea is to say, on this vertical axis here, on the vertical y-axis, this is the amount of carbon we're starting with our insulation on this particular building. And so you can see these like graphite, enhanced polystyrene, fiberglass, and cellulose are all pretty much starting at the same level here, just a smidgen below, a little more than zero, maybe 30, 40, 50. Whereas those higher embodied extruded polystyrenes are way down here at 200, and the other one already at 350. So that's the amount of carbon that you're starting with as embodied energy. And now as we operate the building, these insulations are going to save energy. So as they save energy, they're saving carbon. But how many years do you have to operate the building to pay back for all the carbon that it took just to invest and make that insulation? Well, here you can see on these middle lines, this kind of yellowish and golden lines, you operate the building for 9 years, and it takes 9 years of saving energy in the building because you insulated it with a rigid foam sheathing to just break even for the invested energy that you put here, a little over 200 kilograms of carbon. In the case of the blue XPS, it takes almost 16 years, say 15 and a half years of savings of operating the building in energy just to equal the investment that you put in. Obviously, these other insulation types in this little box, you can see a exploded view here to the right, and you can see graphite polystyrene has a payback in 6 months. And that's if you're using the traditional recipe of graphite enhanced polystyrene. There's some new versions that are out there that have renewable feedstocks that even lower that further. But this is the power of not only having life cycle analysis, but being able to extract the information with an EPD and run it through some of the programs that we showed you before. Now let's take a real quick look at what are some LCAs if we think about vinyl siding versus fiber cement siding or versus brick. So the first over here to the left, vinyl siding versus brick mortar. The vinyl siding by itself has 83% less impact than brick and mortar. 83%. So to put it in other words, here in the box below, you see it's like having a Tesla versus a F-150 pickup. The vinyl siding being the Tesla, and you're using much less energy than the pickup truck. Or if we want to compare over here on the right-hand side, vinyl siding as a finishing product, a cladding product, versus fiber cement, 40% less carbon impact to do the same job as fiber cement. So that's maybe not a Tesla compared to the F-150 pickup, but it's maybe like a crossover hybrid versus a pickup. So this kind of starts to put in perspective the power of using an EPD and why life cycle analysis are so important. If we think about also the fact that when you get to the end of life, we got to do something with these products, and you hope that they're going to be easily recyclable. So when we look at, say, a vinyl polyvinyl chloride product, it's 57% salt. So think of salt from the ocean, you extract that out, you leave the water back, you take that salt, you're able to produce the vinyl siding. So it's one of the lowest carbon intensity polymers that exist out there today. And then when you pair it with a great insulation product like a GPS, a graphite polystyrene, which is 98% air, there's very little density and mass and carbon there to have to pay back over time. And both of them are 100% recyclable. So at the end of life, when you're residing your project, you can take that siding off after 30 or 40 years or whenever you decide to reside, put that in the truck, drive over to a reclamation center, whether it's a local recycling center or it's just a distribution that later sends it to be recycled at another facility. They then collect all those products together, send them for recycling, and then those raw materials, whether it's the vinyl, goes back into vinyl siding, and the EPS can go back into other foam insulation products. So if we want to graph kind of quickly here the various life cycle analysis comparing various fenestration products and facade finishing products, you can have brick here versus exterior insulating finishing systems versus fiber cement siding versus stucco versus insulated vinyl siding versus just generic vinyl siding, and then compared to naturally grown cedar siding. So you can see the environmental performance of all these, and certainly brick is huge on this list. EIFS is about half of that, about equal to fiber cement siding. Stucco is way down here, very similar to what we have with vinyl siding. And then, of course, you have your cedar siding, which is the best. And then you can see the various EPD information for environmental impact that is here on the side. Then what you have to consider is, well, what is my programming for my building? Do I have to worry about other things like maybe fire for siding or something like that? So clearly, a product like we just discussed, insulated vinyl siding, not only is it being a facade treatment finish, but it can help consider your continuous insulation and your regular insulation requirements for your building. So real quickly then, as we kind of sum up, vinyl insulated siding, it can work as continuous insulation. It's lightweight, resource efficient, really low maintenance. And all of that means it's a really resilient product. The bugs don't eat it. You don't have to repaint it. It's going to be there. Maybe a light power wash over the years of service helps it to have super low embodied energy as an installed product, but certainly ongoing maintenance is almost nil. Recyclable. So it really has a variety of different things that you can be proud of as specifying a sustainable product. So lastly, for those of you that want to figure out exactly if you've gotten the gist of what was going on here, what is the difference in this little quiz here between an environmental product declaration and a life cycle analysis? And then lastly, how does insulated vinyl siding compare to cementitious siding products from embodied carbon? So in the event you want to think about it a while, pause this video, and then you can come back and I'll tell you the answer. So the answer for quiz number 1, what's the difference between the EPD versus the LCA? Well, remember the life cycle analysis is the whole huge report, and the environmental product declaration is just the extraction of the environmental information that makes it really easy for comparison. It's maybe a 6 or 8 page document. And quiz question number 2, how does vinyl insulated siding compared to cementitious siding? Well, remember that graph with the bar charts that we showed earlier? It's about half. So very durable product with half the embodied energy. So as we finish today, thank you for your time. Here is a great list of links if you'd like to go to Progressive Foam for insulated vinyl siding examples. There's some links there. Also for the graphite polystyrene insulation, you can go to BASF's Neopor, and then a variety of other resources for you. Thank you so much for your time. And if you want to learn further, lastly, just to let you know, so in addition to the main 1-hour course about not your grandmother's vinyl siding, there's 3 of these little nano courses together. So we just did the first one here, EPD and graphite polystyrene, but there's 2 other ones. So feel free to reach out to those if you want to learn a little more about energy codes and compliance, or if you want to know more about the tax credits and buckets of financial information that are available from the 2022 Inflation Reduction Act. Thank you, and I appreciate your time.